This video is the second part of the lecture 2. Here we are going to discuss the carbon resistors. Now, carbon resistors. Now, you have seen such type of resistors. Such type of resistors anywhere in any electronic instruments. So, these resistances, they are used in our laboratory. Now, these are very small resistance. They are made up of ceramic core on which a thin layer of crystalline carbon is deposited. These resistors inexpensive, stable and compact in size. Now you can see the color rings are used to indicate the value of the resistance according to the rules. So different colors or the rings of the different colors are made on these resistance. Now these different colors, they are helpful in decoding to find the resistance of the resistor. For this, three color rings, they are used. The three color rings, these first three color rings, they are used. First two colors for the significant digits, the third one is for the multiplier, and the fourth ring is for the tolerance. Now if there is no fourth ring, it means that tolerance is 20%. So the different colors have been assigned the different numbers. Just like you can see the color coding for the resistor. There are the different colors which have given assigned different numbers. For the black 0, brown 1, red 2, orange 3, yellow 4 and so on. And the multiplier, that is if number is 1 then 10 raised to power 1, number is 2 10 raised to power 2 and so on. Gold, silver and colorless, then tolerance is 5%, 10% and 20%. Now there is a very simple way to learn the codes of these colors. Now just look at the first letter of the word. Black B, brown B. So B, R-O-Y, say Roy. So BB, Roy. G for great and B for Britain. So BB Roy of Great Britain. V for very, G for good and W for wife. So BB Roy of Great Britain, very good wife. So now you can easily remember the sequence. BB Roy of Great Britain had a very good wife. Then gold, silver and colorless. So by this simple sentence you can learn the sequence and you can decode the color with their numbers. Now let us solve one example. Now suppose if you are given this conductor which has green, blue, orange and gold lines, then how can you find the resistance of this resistor? Now first two digits, the first digit, that is the green stands for 5, so 5. The second digit is blue, which stands for 6. Third digit is orange, which is multiplier, so orange is for 3, so 10 raised to power 3. The fourth ring is gold, which is designed 5%, so the resistance will be given equal to first two rings 5, 6, 56. Third is 10 raised to power 3 ohm. So 56 10 raised to power 3 ohm, or you can say 56 kilo ohm with the tolerance of 5%. So in this way, simply just remembering a simple way, you can decode the resistance of this resistor by giving the different numbers to the different colors, or you can decode it using the formula, and very easily you can find the resistance of the resistor. Now electrical power, energy and power. Now you know that when a battery is connected between the ends of a conductor, a current is established. The battery transports energy to the device which is connected in the battery. So for this to understand it, let us consider a circuit. Now this is a circuit in which a battery is applied across the resistor CD. Now let us assume that current is flowing from A to B, then to resistor C to D and again to the cell. Now for to understand it, let us consider that a small energy dU is, you can say that small positive charge dq moves from point A to B. Small and charge from A to B, that is, it is small charge dq is moving from A to B inside the battery. So it is absorbing, or it is taking the energy from the battery, and then when this charge is passing through the resistor CD, then due to the resistance of the resistor, this energy is consumed here. Again the charge is passed through the battery and it absorbs the energy. The same process continues. So this process occurs continuous till the battery is connected in the circuit. So the rate at which the charge loses its electrical potential energy in the resistor can be calculated. The electrical power P is the rate at which the electrical energy, potential energy is delivered, and we know that P is equal to du by dt. The U is V into dq. So by putting these values, we can find P is equal to V dq by dt, and since dq by dt is the current I, so we can get the P is equal to V into I. So electrical power is equal to V into I. Now this expression gives the power delivered by the battery to any electrical system. So I is the current and V is the potential difference across it. Now we know that unit of the electric power is watt. 1 watt is 1 joule per second. Commercially, the electrical bulb used in the houses comes with a power rating 5 watt, 220 volt, 30 watt, 220 volt, and so on. In houses you have seen that the bulbs that something is written on the bulb, that is 60 watt, 220 volt, 40 watt, 220 volt, or whatever it. These is known as the power rating. Now what does it mean? Usually these voltage ratings refers to the AC RMS voltage. As we know that at our homes alternating current power is supplied to our homes. So for the given bulb, this is for the power voltage rating. Now if the voltage drop across the bulb is greater than the voltage rating, then bulb will fuse. Now suppose if 220 volt is written and power supply is more than 220 volt, the bulb gets fused, and which it is a very common phenomena which we used to come across at our home. Sometimes when power supply is high, then the bulb gets fused. So using Ohm's law, power delivered to the resistance R in the form, we can change the expression P is equal to I square R or P is equal to V square upon R. Now from this expression it is clear that the current occurs the square times. So means current has more effect on the power in this relation. Similarly for this relation also we can say that voltage occurs the square of the current voltage. So if the voltage is doubled, then power will increase accordingly. A current of 1 ampere flowing through a potential difference of 1 volt produces a power of 1 watt. Now let us discuss the next and the last topic, resistors in series and parallel. This is the last topic of this lecture. Now resistance in series. Now in series means when two or more resistors are connected end to end, they are said to be in series. The resistors could be simple resistors or the bulbs or heating elements or other devices. So let us consider that the three resistors R1, R2, R3 are connected in series. So when they are connected in series, the amount of charge passing through resistor R1 must also pass through the resistor R2, R3, and the charges cannot accumulate anywhere in the circuit. The same thing you have studied in class 10 also. So it is a very easy topic. So we see that when the three resistors R1, R2 and R3, they are connected end to end. So this such type of arrangement is known as the series arrangement, or the three resistors in series. Now this is the equivalent resistance. Now if in place of R1, R2, R3 the equivalent resistance is Rs, then the circuit will have this form. So equivalent resistance RS has the same current. Now due to the reason that the current passing through the three resistors is the same, according to the Ohm's law, if some same current pass through the different resistors of different values, then the potential difference across each resistor must be different. Let V1, V2, V3 be the potential difference, then V1 is equal to IR1, V2 is IR2, V3 is IR3, but the total voltage is V. So we can say that V is equal to V1 plus V2 plus V3. By putting the values, then we get V is equal to IRS. Now simply comparing these two equations, these two equations, we will reach to the conclusion that R is equal to R1 plus R2 plus R3. That is, when several resistances are connected in series, the total or equivalent resistance is the sum of the individual resistance. Now resistors in parallel. Now resistors are in parallel when they are connected across the same potential difference. In this case, the total current leaves the battery is split into three separate paths. Let I1, I2, I3 be the current through the resistors R1, R2, R3 respectively. Due to the conservation of charge, due to conservation of charge, total current in the circuit I is equal to the sum of the current through each of the three resistors. So this is the arrangement in which three resistors R1, R2, R3, they are connected in parallel to each other. This current I comes and divides into all the three I1, I2, I3. All the three resistors, they are connected through the same voltage. So this is the equivalent resistance Rp and the equivalent circuit diagram. So here I is equal to I1 plus I2 plus I3, and the voltage across each resistor is same, so we can say that I1 is equal to V upon R1, I2 is V upon R2, and I3 is V upon R3. Substituting these values in this equation, then we will get that I is equal to V upon R1 plus V upon R2 plus V upon R3, or also I is equal to V upon Rp. So from here, by comparing these two, we will get that 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So when the three or more resistance are connected in parallel connection, then the resultant or the equivalent resistance in the circuit will be lesser than the individual resistance, while in case of the series, the resultant resistance will be more. Now all household appliances, they are always connected in parallel, so that even if one is switched off, the other devices could function properly. Now let us discuss some numerical based on the topics taught today. These are some examples with the solution. You can go through with these examples and understand these examples. If you have any problem in this example, in these numericals and the solutions, you can discuss these with me either through the video call or through the WhatsApp, and wherever you feel comfortable. But practice all these numericals, because in tomorrow's MCQ test, some of the numericals may come in that MCQ test. So prepare these two part properly and revise everything for the MCQ test. Thank you.